Hey, so to continue the notes, part one for 6.8, I'm going to just go over these examples on the left side, and hopefully you try these examples on the right side. Let me know in class if you want me to check if you got them right or not. So this first example is giving you a polynomial function, and you need to look for the key attribute. So for example, right here, it's touching at -3, which means it has a root at -3. That will create a factor that follows the x minus the number, which creates x minus -3. And that's going to result in x plus 3. On this side, we're going to have a positive 5. And then when we write the x minus the number factor, that's going to result in x minus 5. So these are the factors we're going to use for our function. X plus 3 and x minus 5. And then now we need to annotate the multiplicity, the exponent that each factor is going to have based on what's happening in the graph. So right here, we're noticing that it's bouncing off of this root. Because it's bouncing, we're going to have a even multiplicity. And we can start with a 2. If needed, we'll adjust, but for now we can just start with a 2, and then if not, a 4 or 6. Here we're going to have an odd multiplicity because it crosses this root. So we can start with the 1. Usually when it's a flat straight line like that, it's a 1. It's just to the 1. If it's like a curve, that kind of creates the template of a third power. So just keep that in mind. All right, so next we want to look at the leading coefficient. We're going to have a positive or negative. So we look at the ends. So for this part, we're going to look at the ends. This one's going left up, and then this is going down right. So we kind of sketched that on the side. It's creating a down up and down right. So it creates that line, a line that is going negative. So it's a negative leading coefficient. So we're going to put a negative in the front. And then as far as the degree, we notice that it has 1 turn, 2 turns. So that's 2 turns, which results in a degree that is higher. So the turns are always 1 less than the degree. And then it all connects here when you look at it. The degree is 3, which is an odd number. And that's why the graph has a end behavior of different directions. Okay, so now let's take a look at the graph in the calculator and see if it's correct. So we came up with this function right here, negative, and I'm just going to type it, negative parentheses x plus 3 to the second power times x minus 5 to the 1 power. And if I graph that, it's not going to look exactly like what I have sketched because you need to adjust the window in your calculator, this window right here. So we're looking at the window, we're looking at the minimum and maximum of the x, and then the minimum and the maximum of the y. We're going to go to window to menu and then window and settings and change that. So x minimum is going to be -5, x maximum it's going to be a 6, y minimum it's going to be -60, and then y maximum is 180. Now this window sort of looks like what we have here in this example, but then the graph looks, like students said earlier, a little flat. So what I asked students to do is verify the other attribute right here, the y-intercept, to match what we have right here. So when we go to menu and trace, graph trace, we realize that the y-intercept right here is 45. And according to the graph, it needs to be 90. So 45 to 90 means that we need to multiply 45 times 2 to become 90. The only thing we can do here is manipulate the leading coefficient and put a 2 there. That will make sure that we multiply the function times 2. So we're going to edit what we typed, put a -2 in the front. And then now the graph looks very much similar to what we have right here. Okay, so that confirms. And of course, we can always trace it and just verify. So it's 0.90. All right, so that's the first example. And then just to speed things up, you don't have to go in super detail. Pretty much you want to identify the degree, the leading coefficient, the factors, the multiplicity, and all of these could be just put together to find our function. So let's start with this. It's touching on -3. So we know one of the factors is going to be x plus 3 because it follows the template of x minus a number. And then if it's minus negative, it becomes plus. It's also touching here. So we're going to say that that one is going to be x plus 1. And then it's also touching here. So that's going to be x minus 2. So those are the factors based on the roots. Got it. Next, we're going to talk about the multiplicity. So we can see here that it's crossing. So if it's crossing, it's going to be an odd multiplicity. Right here, we notice that it is sort of turning, but it's not turning and bouncing. It's just turning and crossing. So we're going to consider that also a crossing. So it's going to be also an odd multiplicity. So these two so far are odd, but these two are different. This one is just straight crossing, and this one is curve crossing. And as I mentioned above, when it's kind of like a curve, that's to the third power. So we're going to say this is 1, this is 3. And then the next one, it is a touch and bounce off. So that would be an even multiplicity. We're going to put a degree of an exponent of 2 on that one, a multiplicity of 2. So if we add these multiplicities, they will give us our degree. So that's 3, 4, 5, 6, degree of 6. We're going to triple check that the degree is correct by counting the turns. Remember that the turns are one less than the degree. So if we, as I explained to the students, if you're driving, you're turning here, so that's 1. And then you're turning right there, so that's 2. And you're turning right there, so that's 3. And you're turning again, that's 4. And then you're turning one more time, that's 5. So that confirms that our degree is 6. All right, so for the leading coefficient, we're going to look at the end behaviors. So the end behaviors are both the same direction and up. And if it's going up, that's going to be a positive leading coefficient. And then the fact that it's up, that means that it's an even degree. So that confirms that 6 is an even number. And then the leading coefficient is positive. At this time, I don't know specifically if we need to change the number of the leading coefficient other than 1. So let's graph and check, and we can verify. So I'm just going to change the window while I'm at it. The window for this one seems to be -4, +4, -40, and then +30. So I'm going to go ahead and type that. And if you don't have this calculator at home, you can always go to the website of graphing calculator of decimals.com. And let me keep retyping this, sorry. Thanks for waiting. Okay, and then we're going to change the window to follow this. So the minimum is going to be -4, maximum +4, minimum -40. And we'll just do +40. All right, so this does seem like what we have. Specifically, we can check by tracing. So right here it says that the y-intercept is 12, and it looks like it's at 12, around there. It looks like it's a maximum of around 1 and 30. So I'm just going to move this and see what the maximum is here. So it does seem to be like at 1 and 30 something. The root is touching at 2. So all these attributes so far seem to work. So we're just going to say that everything else works. All right, so the last example below, it's now giving you the equation and then you need to sketch it. So definitely right away, that's leading coefficient, that's negative. When the leading coefficient is negative, it could follow the template of a negative line or a negative, and behavior both directions. The difference between these two is the degree. This is if the degree is odd. This is if the degree is even. So let's count the multiplicities to find the degree. There's 1, 1, and 2. So that's a total of 4. So because we have a degree of 4, we're going to have this even degree and behavior. Now, where is it touching? The factors tells us where. Remember, it has to follow the template of x minus a number. So this is the number 2. So it's touching at 2. X minus the number. So it's touching at 5. And then x minus a number. So this one is not x minus, so that means it's at negative 2. The multiplicity tells us if it's going to cross or bounce. The odd tells us that it's going to cross. So this one is going to cross, and then cross. And then this one's even. So we're going to bounce off of that one. But the dilemma is we don't know if it's bouncing up and down or if it's going down and up. So what matters is, again, looking at the end behavior. So we know it's finishing down and down. So we're going to say that it crosses right there. This is going to bounce right here. And then it has to turn somewhere and cross, and then turn and cross. So specifically, I don't know how to tell you where the maximums and minimums are for those at this moment. But as far as where is it touching and what's happening when it touches, that can be found just from the multiplicities and the factors. So I hope this video helps you understand a little better. Go ahead and try the practice problems that are right here. And if you have questions or want me to clarify, let me know during class.